people propose? They propose that, the universe had a beginning, meaning matter had a beginning, and it's worse than that. It's space had a beginning. I mean, I can imagine creating something, but I create nothing every day. It's easy to create nothing, and this is where I have a problem, mainly in the creation of nothing, creation of space, of vacuum. How do you create nothing? Create something we can all try to imagine, but creating nothing, that's kind of tough. What do? You turn something into nothing? Is that what the trick is? I mean, I don't know. You need a magic wand or something more than that. You need an explanation if you're going to believe in that kind of nonsense. Okay, so what is the traditional version? A lot of religions have this, especially Christianity, which is the most popular in the West at least, right? You have God creating the universe, okay? What is it called? In the beginning, right? God created the heavens and the earth. So he just waves his magic wand, I guess, and suddenly, you have heaven and you have the earth. I guess heaven precedes the earth. At least in the Bible it does, so I'm assuming they didn't come into being at the same time, okay? So that's one version. That's probably the most important version that you see out there, at least from the point of view of religions. They say, look, there was a God who created the universe, and we don't know anymore. And of course, nobody can explain that because they just say, you got to believe it. That's it. There's no explanation for it. There's never been an explanation for that. What's changed? Well, what's changed is that relativists claim that they know. For the first time, we don't believe. Now we know. We know, we've proven, right, that the universe came into being, came into existence. And how do they say it? Well, they say it more or less like this. Here, I've illustrated that as well. Okay, God waves his magic wand and creates what is called as the Big Bang. Okay, and that's our universe there, right? That's we're at the edge of the farthest, rightmost edge there, right? The rim of the cup. Okay, the cup is lying down, and it's the rim of the cup. That's the present. But essentially, God waves his magic wand and creates the universe. What's the problem? The problem is that God really disappears. They do this, but they got rid of God. That's what they did. That's the only thing that's changed. But other than that, we have essentially magic. Okay, it's magic because again we have this magician that waves his magic wand, but there's no magician. Okay, we get rid of the magician and just all of a sudden, matter by itself comes into being, and space itself comes into being. That's the worst part of it, which is kind of weird. So that's what we have today, okay? Religious folks, some of them, like born-again Christians, people like William Lane Craig, what he does is he incorporates the stuff from relativity. He doesn't want to challenge that because he said, well, that's science and they've proven it. So why don't we incorporate it into Christianity? And so what people like him do is they incorporate the Big Bang Theory and God. They have both of them in there. So here we have God, okay? And God waves his magic wand, right? And he creates the Big Bang first, okay? The Bible doesn't talk about that, but he says, well, that's probably what happened. And then from there, you have, the heaven and the earth. Okay? So that's the new version of Christianity, and or the one that's going to be popular in the future. Big Bang precedes heaven and earth. Okay, but we can't get rid of heaven or earth. Okay, so there it is. Okay, so those are the proposals out there, the theories of the establishment and of traditional religions, more or less. Okay. Again, very different than what we propose. We're saying there's a single thread, did not come into existence, always been there. And sometimes I like to reinforce for people what it means to be, what the word eternity means, forever. People talk about forever, like, oh man, I waited forever at the doctor's office. Yeah, that's not forever. That's not eternity, okay? Eternity is something else. I like to put it in the right context so that people are aware of what these words really mean, what they imply, okay? When we say the universe is eternal, that it's been there forever, will be there forever, what are we saying? Well, here's an example that has to make you lose sleep at night, okay? So if you don't want to lose sleep at night, turn your TV off right now. You don't want to hear this, okay? We go back a million years. We take the time tunnel, right? We go back a million years, like the Relativity says, and we look at the universe as it was a million years ago, okay? Straightforward, okay? Never happened, but we're just going to make believe here, right? We go back in a million years, we're going to find a planet somewhere in the universe, other than the Earth, right, that has life, where maybe there are humans, okay? Okay, now we go back behind that a billion years, okay? Or maybe even a trillion years. You like a trillion years? Let's go a trillion years back in time, and we're going to find a planet somewhere in the universe, like the Earth, that has life and maybe even humans. And we go back another trillion years, and we find the same thing, a planet somewhere in the universe where there's life, where there are humans. And we go trillion years, trillion years, trillion years, quadrillion years, we'll always find a planet where there was life and where there were humans somewhere in the universe. There was never a first human in the universe. There was never a first entity that was living, that was alive. There was always one billions of years before that. Okay, you get the picture? And you say, well, hold it, when did it start? The movie never started. That's the point. The movie never started. You will always go back in time, if you can travel back in time, through the record and find living entities trillions, gazillions of years ago. That's known as eternity. It's known as a present. The present is eternity. Location is eternity. So once you get a hold of that, then yeah, you got a lot to think about, okay? But anyways, this is how relativists, more or less, the establishment explains the Big Bang and how it came into existence. Let's see if you can follow along, okay? Here it is. Listen to these folks. This is the official version, more or less.
Big Bang cosmology transports us back to the very origin of the universe, a realm where the conventional laws of physics as we know them reach their limits. The Big Bang wasn't an explosion in space. Rather, it was the rapid expansion of space itself. At the heart of this expansion is the concept of time. But how was time created? At t=0, the moment the Big Bang occurred, our universe was a singularity. In this state, density and temperature were infinitely high. At such scales, our current understanding of physics falls short. This singularity marks not only the birth of matter and energy, but also the dawn of time. Before this moment, the traditional concepts of time and space lose their meaning.
The big question then is, well, what started the inflation? What stopped the inflation? How long did the inflation go on for? And the answer to that is, we're not sure. We don't know.
So what's the answer? The answer is, we don't know. Whenever you ask your relatives, he'll tell you he doesn't know. So why do we ask these people? They're all ignorant people who don't know. And that was Brian Cox, by the way, answering the we don't know stuff. Yeah, they don't know. They don't have a theory. They just say, we've proven it. It's a done deal. Big Bang happened. The universe is collapsed upon itself if we went backwards in time. And so they have this spatial expansion, space-time expansion, because it's both space and time, right? And that's the theory. That's the reigning theory right now, and take it or leave it. Whether you like it or not, that is what you got to believe in, because that is the religion of today, okay? Propagated by relativists, right? Mathematicians who know everything, except when they have to answer those questions. Okay, so what are the fatal problems with this theory? Here's a summary, okay? That's what I'm going to be talking about right now. These are the fatal problems with Big Bang, with this spatial expansion, the expansion of the universe, as they call it. Galaxies receding all from us, all redshifted, right? And so we have first the notion that redshift was misinterpreted. Okay, they say redshift is this thing that when something recedes from you, you know, Doppler effect, when it recedes from you, the light goes towards the red, whereas if it's coming towards you, it gets towards the blue. That's it. That's all you need to know. Nothing more than that. But redshift means that if it's going outwards, it's going to be redshifted, and since they look through their telescopes or through their X-ray telescopes or whatever machines that they use, they realize that the whole universe is tending to redshift, and so they say the whole universe is expanding, it's running away from us, like if we were the center of the universe, more or less, right? And they have an explanation for that. They say it's the expansion of space itself that's pushing all the galaxies, all the stars farther away from each other. That's more or less the theory. You don't need to know more than that. And so the question is this redshift correct? Is this notion of redshift correct? Then you have the singularity definition. You know, they have essentially two types of definitions for the singularity. They have no way of explaining how nothing converts to something, okay? They don't have an explanation, mechanism for it. Then they don't have a definition for something and nothing. These two words are crucial if you're going to talk about something converting into nothing and vice versa. Well, you better have definitions at least as a minimum. They don't have definitions for either something or nothing. They say it's not their job. They do equations. They don't do philosophy, as they call it, or ontology, or language, or whatever they call it, semantics, right? Word salad. And then we have the issue of the space shape of space-time. What's outside of space-time? What is space-time expanding into or, you know, pushing against? A lot of people ask that question. It's a normal question to ask, and is it a valid question? That's the first one we're going to analyze. And of course, if you can't answer that question, your theory falls apart. That you're, you know, that there's an expansion of space, because you need to tell us what it's pushing up against or what's expanding into. If you cannot answer that, if you don't have a mechanism, you cannot tell us what's outside of space-time, you do not have a theory. Okay? Your theory dies right there, because that is the crucial question, and which is the crucial question that all these people try to avoid. Okay, so let's go with the definition of redshift. What is redshift? Here it is, the official version: an increase in the wavelength and corresponding decrease in the frequency of electromagnetic radiation, such as light. And they say the main causes of electromagnetic redshift in astronomy and cosmology are the relative motions of radiation sources, which give rise to the relativistic Doppler effect. In other words, they're saying that the only version that they have for why something is redshifted is the motion of the sources. And in the case of red, means they're moving away from us, okay? All sufficiently distant light sources show cosmological redshift corresponding to recession speeds proportional to their distances from Earth. In other words, the farther away they are, the more redshifted they are. Very interesting, right? I mean, is that the only explanation? Means that if they're very redshifted, they're just farther away and running away from us at a faster speed? Is that what it is? Okay. And they say it implies that the universe is expanding. Well, I don't know about that. We'll find out that maybe there's a different explanation for this thingy they call redshift. Okay, and here's one explanation, the one we give in the under the rope model. It's known as tired light. Now, the mathematicians were aware for many years of tired light. They rejected it because tired light means that light bounces against something and loses its energy, right? And because it loses its energy, now it becomes reddish, because now its wavelength is longer and the frequency is, lower. And so how do we answer that? Well, we have a different version because it's based on the rope model of light and gravity. And here you see our version compared to theirs. The one on the bottom, you see the the spectrum there. When it's close to you, you have a blue shifted, short wavelength. and high frequency. And when you're far away or running farther from the Earth, then you would have the redshift, which is the elongated wave, okay, and lower frequency, fewer waves, right? And what we're saying is what they're explaining is a rope, essentially. Only a rope can model the spectrum. And what we have is, as the thing is farther from us, it doesn't have to recede from us, but if it's farther away from us, you should expect it to be in the reddish zone, because that is the Doppler effect. What you're saying is that the wavelength is longer. In other words, the links are longer and you have fewer links. And after a while, you get into the infrared, into the X-ray and gamma rays, which means that you can't see them at all with your eyes. Now you would need some kind of instrument to see it. Okay? And so the explanation does not require first waves, which are not physical entities, which cannot serve as mediators for light, which is what they use. Okay? And the other thing you should keep in mind is, aside from the fact that the rope can explain this very easily without having any motion whatsoever, it's just a question of distance. Farther out, you should have in the infrared, a little closer you have in the red, and even closer you would get in the orange or whatever. And that's exactly what we see. What you see at the bottom left, you see the what is known as the local group. Okay, and the local group has many galaxies in this region. I think they counted like 56 galaxies. And most of them, if not all of them, are blue shifted. Well, not all of them, because some are rotating around, and so at some point in time they're getting farther away from us. So not all of them are red shifted or blue shifted. But most of them are blue shifted, meaning they're very close by. Okay, and if they're close by, then you can see why they're blue shifted. Of course, the farther out you are, like the ones on the top there, it should be in the red zone, in the red shifted zone, and in the infrared and X-ray sources and so on. And the closer you are to the Earth, well, they would be blue shifted. So, we have an explanation for this without any motion whatsoever. Of course, if you factor motion as well, right, then you also have this blue shifted and red shifted, because the Doppler includes for light includes two factors. One is the motion of the galaxy, and the other one is the distance. Okay? If it's farther out, we should expect red shifted. If it's close by, like the ones in the local group, just by sheer coincidence, they're blue shifted. And at the same time, when you have a galaxy that recedes from us, it should also be red shifted, or comes towards us blue shifted. So we can explain it without motion necessarily. Okay, you can explain it with just distance. Okay, whereas the only explanation they have is first with waves, which cannot serve as mediators for light, because there's no such thing as a wave. Fields and vectors; those are mathematical concepts. That's one issue. And the other one issue is that they only have the Doppler effect, like sound. When the car comes towards you, it compresses the waves, the sound waves, and you get this. And when it leaves, it goes. It goes down. The frequency goes down. Okay. So they only have an explanation with motion. We have one without motion. We have it only with distance, and that's what Hubble's law is telling us. The farther out they are, they should be red. Hopefully. Okay. Here we have good old Einstein. He proved, I guess, that gravity pulls on waves. How that happened, I don't know, because waves are not physical entities, and gravity is what we're trying to prove. We're trying to understand gravity, and to say that gravity, a concept, pulls on a wave, another concept, well, it's kind of stretching your imagination. But that's what Einstein proposed. He says that if you're in a gravitational field, meaning a mathematical concept, meaning measurements that you take, values at different points in space, well, the closer you get to the center of gravity, in this case, the center of the Earth, right? The light should be blue shifted, whereas the farther out you are, you should get red shifted, okay? That's more or less what he proposed, and it was shown by a couple fellows, Pound and Rebka, right? And what they did an experiment known as the Harvard Tower experiment. There you see the tower in the center, essentially, right? And one guy was at the top of the tower, Glenn Repka, and the guy in the bottom, Robert Pound, and they measured a slight change in the frequency that they sent upwards. Okay, I think they sent it in both directions, and they confirmed that, yeah, it is redshifted as you get upwards, or the frequency declines, right? And as you get towards the bottom, the frequency increases. That's all they measured. And yeah, we don't need to measure anything. We can just explain it with a rope. You take a rope, right, and you tie it from one wall, or from, I guess, from your floor to the top of the Eiffel Tower, and hopefully the rope, as it goes outwards, the length should become longer. Okay, and that's all they measured. And again, the rope spectrum is better than the wave spectrum, right? Because wave is not a physical entity, so we do it with ropes. And yes, the length should be longer the farther away you are from the source of that light. So no mystery there as far as we're concerned. We don't need to have anything in motion. We can explain it simply by taking grandmother's rope where she hangs her clothes, right? And we can show that the farther you are from one point where the rope is attached to the other point where it's attached, the length should become longer towards the center. And that is the redshift without any motion whatsoever. Okay, what they're proposing essentially under the rope model is quite ridiculous, which is this. They're saying that all the ropes from the Earth connected to a rope between two atoms is pulling on the rope itself. You know, the ropes are not attached to ropes. Ropes are only attached to atoms. But these people are saying that gravity, which is a bunch of ropes under the rope model, is pulling on the ropes itself and bending the ropes. Okay? And that's why under the rope model, it's even more irrational to talk about gravity pulling on light, meaning on the wave, meaning on the frequency, you know, stretching the frequency or whatever. So yeah, it's totally irrational under the rope model, okay, what they're proposing. Okay, here we have the singularity. What is the definition of a singularity? And we go with the version, the official version there, and we have the R2D2, the AI overview, right? It says a singularity is considered a what? Tiny point in space-time. So what is a point? Is a point a thing, or is it a mathematical concept? What is a point? Is it a location? What are we talking about when we say point? And so people get confused because they don't know if they're talking about something with zero volume, meaning location, which is a concept, or they're talking about a little ball that is at that location. Which of the two is it? You know, so they have these two notions. They use both of them simultaneously, and they get away with murder because they make you think that there's a little ball, and also the ball is not there because it's zero dimensional, zero volume, zero shape, zero size. You know, what are we talking about? We're talking about a concept. We're talking about nothing, but they're saying, you know, there's a point there. Whatever point that is. What's a point? What's a little ball? That's what it is. So, yeah, they go back and forth. And the problem with that is that you cannot say that it's nothing, because then they talk about the rotation of a black hole, which has a singularity at the center. So what is rotating? What is spinning? I mean, if it's nothing, if it's zero dimension, zero volume, zero shape, zero size, you have nothing spinning. You cannot even conceptualize spin. So if you're going to talk about spinning black holes, there had better be a little dot, ball, or whatever you want to call it, a little grain of sand in the center of that black hole. There's got to be something there for it to be spinning. Okay? And that's the question. What are we talking about as far as physics? Not math, but physics. It says often associated with the center of a black hole or the initial state of the universe in the Big Bang Theory. Yeah, so they start out with this singularity, whatever that is. And of course, the question everybody asks, that is a rational individual, right? Says, where did the singularity come from? How did it come into being? And that's when they have a problem, and we're going to answer that question today from their point of view, okay, by the way. Okay, and then in the Wikipedia, see a complete and precise definition of singularity in the theory of general relativity remains a difficult problem. No, it's not a difficult problem. They never defined it, then they can't define it because it's a mathematical concept. And it's a concept that includes infinities, meaning you fall forever into this physical thingy called a singularity, and you never get there. And so it's like it's something that's there, but you never reach it. But then we have a problem because they say that a black hole crushes all matter out of existence. That cannot be the case because nothing has reached the center of the black hole, meaning the singularity, means that everything should still be there between the singularity and the event horizon of a black hole. So we have a problem because it means matter was not crushed out of existence. Okay? There's a contradiction. Either it is crushed out of existence and goes into another universe or turns into empty space. Okay, that's one possibility, and there's no center, meaning there is a center to the black hole, but the center is not a ball, not a thing. Okay, so it cannot rotate because it's the center, like the center of the circle is not a thing. Okay, but on the other hand, if it's just a place where we have a little hole that leads to infinity, then nothing has fallen, or nothing has fallen through the little hole, through the singularity, and all you have is matter just falling forever and never making it out of the black hole. It's still there between the singularity and the event horizon. So which is it? And again, they'll never answer that question from a physical point of view. They'll just say, we don't know, we're still investigating, we're studying. Okay, general relativity predicts that any object collapsing beyond a certain point would form a black hole inside which a singularity covered by an event horizon would be formed. So they're forming a singularity. What is a singularity? Well, they don't know because they haven't defined it. Like you see above, they have problems defining it, right? And then, however, quantum mechanics does not permit particles to inhabit a space smaller than the quantum wavelength. So now we know that the singularity is small, infinitely small, but not smaller than a quantum wavelength. And it says the singularity cannot be defined by where or when. That's strange because I thought that when you fall to a singularity, you fall to a where, to the center of the black hole. It turns out there is no where, they say, or when. You figure it out. It's just too much for my brain, okay? I don't know how I can fall to a nowhere when it's the center of a black hole. We know, and they said they've discovered black holes here, there, and everywhere. They're looking, every day you have someone writing a paper on black holes. And they found one, the closest one, the biggest one, the fattest one. They've got them all, right? The oldest one. And so they know it's there. They take a picture of the black hole, they show it to you, and you say, okay, so we know where it's the center of that black hole. There's a singularity, right? So we do have a where for the singularity. But in order for them to elude the question, they say, we don't even have a where for the singularity. So they don't have a where, they don't have a when, they don't have a definition for singularity, but they know for a fact they've proven that black holes exist. That's where we're at, okay? They never define something or nothing. I don't think we need to go through that. But all I can say here is what Mr. Hawking said, just to make sure that people understand that black hole is zero-dimensional, zero volume, no shape, no structure, no size, no nothing. That's what the center of black hole is. You have this star, big star that collapsed upon itself, right? Gravitational collapse on itself. And what happens? It turns into absolutely nothing because nothing remains. All matter is crushed out of existence of that star, this humongous star, right? And it's crushed out of existence. There's nothing there, okay? So we have zero matter. And zero matter amounts to zero mass because mass is defined as the quantity of matter. We have no matter, so we have no mass. So the black hole not only has no size, no shape, no nothing, volume, right? It's got no mass either because it's got no matter because it was all crushed out of existence. What are we talking about? Well, it looks like the definition of nothing. It's a pretty good definition for nothing. That's what a black hole is, nothing. And then they tell the astronomers, go look for it, right? Through your telescope. Look for nothing, okay? I found nothing, yeah. So here it is. We have these two fellows. Let me get this out of for a second here. Give me a second here. We have Eddington, according to Stephen Hawking, right? It says, Eddington was shocked by the implication that and refused to believe Chandrasekhar's result. What was Chandrasekhar saying? He's saying that a black hole collapses to zero radius, which is what the fellow on the right also says. Mr. Chaudhuri, he's from Cambridge, and they confirmed that a black hole is zero-dimensional. The singularity is zero-dimensional. So they are talking about an object that has no size, no shape, zero-dimensional. I don't know how else to tell it to you. And I hope, Hawking is good authority for this, right? I mean, if you're going to believe in authority, why not believe in Stephen Hawking, right? Eddington thought it was simply not possible that a star could collapse to what? To a point. Einstein himself wrote a paper in which he claimed that stars would not shrink to what? Zero size. And then they gave Chandrasekhar the Nobel Prize in 1983 for discovering that a black hole collapses to zero size. Okay, so when they ask you what is the size of a black hole, all black holes have the same size, all black holes have the same mass, zero, right, in both cases, zero volume, zero size, zero everything, and zero mass, because it's got zero matter, because all matter was crushed out of existence, whatever that is. I don't know what they were when they existed, but for sure when they say out of existence means it's no longer there. It turned into empty space, I guess. I don't know. So again, they don't define these terms because if they define them, they lose the bet. That's what it is. Their theory goes down the drain. Okay, and just in case, here's a paper written, I think it was quite recently, but this is from a fellow, one of the universities there, Durham University in the UK. Singularities are regions of the universe where space, time, and matter, right? Matter, things like atoms, right? Are crushed and stretched into non-existence. They're out of existence. Okay, so matter is crushed out of existence. Okay, no more matter, which is, what mass is. Mass is the quantity of matter, right? So they're saying there's no matter, there's zero matter. What does that do for mass, right? This is a very serious problem, as if singularities were to really exist in our universe, it would be catastrophic for science. So this is what I was saying, that on top of that all, just in case, he's saying singularities don't exist. Because if they did exist, we would have problems in physics, okay? Love it. We could no longer use the equations of physics to predict the future from the past and present, okay? And for these reasons, most practicing scientists expect that singularities are not physical. Okay, so they're not physical. We don't have anything that's physical. We don't have anything that exists. What are we talking about? What's this got to do with physics? Okay, we have problems because these people are telling you we've proven it. We can see the black hole. Here's the picture of a black hole, but the black hole is made out of two pieces, two parts. One is the singularity, one's the event horizon that encapsulates the singularity, which is nothing but the center of the event horizon, which is some kind of membrane, I guess, another concept, right? And they say that singularity is zero-dimensional. All matter is crushed out of existence. We have absolutely nothing. And of course, they don't define nothing in something, and therefore they can talk to you forever about these things, never make any sense, because they don't have to make sense since they don't have definitions on which you can sink your teeth in, right? Okay, how about the shape of space-time? Well, here, first let me show you this. Here's good old Bugs Bunny. You've seen him in his hole. He goes into the hole, comes out, and Elmer Fudd, tries to kill him or whatever, or get him for some reason. And this is how he looks here on Earth. This is how he would look in space inside a black hole, because a black hole is absolutely nothing. So I guess half of good old Bugs disappears. I mean, I don't know. You tell me. Or how about this one? You play golf. Well, here you have a hole-in-one here on Earth and a hole-in-none out there in space. I mean, what the hell is that? What do you mean a hole-in-none? Where would the ball fall if you're talking about zero-dimensional black holes, zero-dimensional singularity? What is a hole in space? This is what they're saying. What is the hole into? They're saying it's a hole in space. So the star collapses until it perforates space, perforates nothing. I mean, you talk about perforating, making a hole in something, but a hole in nothing, that's very hard to picture. Okay? So yeah, the shape of space-time is a problem. Here you can see it with the Universal movie. Okay, We start at frame number 2 because the singularity is always there, according to general relativity, but we want to know what happened at frame 1. How did frame 1 suddenly, you have frame 2, how did it come up from frame 1 where there was nothing, I guess? Even though that little dot includes nothing as well, includes space. So the question is, if space, time, and matter are in that little dot in frame number 2, inside of that dot, because everything's expanding there, space, time, and matter, right? What was there before then? I mean, if space, time, and matter is the little dot, what's the black stuff that encapsulates and gives shape to it? And so they say, well, it's an irrational question. You cannot ask that question because space-time is everything and it's expanding in every direction. And so it's like it exists simultaneously everywhere, like God, he's everywhere, right? And so, it looks like these concepts are being borrowed from religion, not from science. Here it is. You can see it better here. A single frame, right, of the Universal movie. And this is frame number 2, where you see the little dot for the first time. This is space, time, and matter in there, trying to expand. And the question is it a valid question to ask what's outside of space-time? What is the black stuff that gives shape to it? I mean, they're illustrating this singularity, right? That's going to be expanding. They're going to show it in motion, right? And if they do that, then it's a valid question to say, well, can you label that black stuff for me so that I know what you're talking about? And they're saying, no, we can't label that because it's an irrational question, because that little dot is everything. Well, illustrate it for me, please. If it's everything, don't put the black stuff. Remove the black stuff. What do we have if nothing is outside of space-time? So yeah, it's a valid question. It's just a question they never can answer because they don't know what an object is. An object is that which has shape. In order for it to have shape, it must have a backdrop, a background. It's got to have something, a contrast of some kind. You cannot conceive of any object, imagine it, without some kind of backdrop. And so this is the problem. The problem these people are eluding the only question they must answer for their theory to have any validity. Otherwise, their theory, which is the explanation, right, which they're giving you, they're saying, look, if we take the universe back 14 billion years, we're going to end up with this little dot we call the singularity. Okay, no problem. I'll take it. Where did the singularity come from? What's outside of it? Those are valid questions. And for them to say, well, there was no time before then, okay, I don't know what that means, but you're saying that this little dot, this thing, which has space, time, and matter in that little bottle, in that little, genie bottle, right? If it's expanding, it's a valid question to say, what's the backdrop? Please illustrate it for me without a backdrop. You're not going to be able to do it because an object is that which has shape, and a shape always requires a backdrop.